Excuse me, sir.
Yes, sir.
Sir, what are we doing?
Sorry.
Sir, we have started with what, sir? What are we doing?
Abhay, you're not audible. Can you repeat for saying?
Sir, is it audible?
Yeah, it's better now. Yes, Abhay, tell me. You were saying something. With so up to last class, Abhay was saying something. With
सर अभी तक क्या करा है सर?
कुछ नहीं, just शुरू किया. So this is the first question. This question is also based on Coulomb's law. Note down the question, then we'll start calculations. Note down this question.
Sir, am I audible now?
Yes, sir. You're audible. Yes,
Sir,
sir.
I was asking, like, can you explain, like, what is earthing?
What is earthing?
Yes, sir.
Earthing simply means the process of sharing charge with earth. Like if you have a body, this have a negative charge here and this have a positive charge. So if you connect this body with earth, like if you earthed this body, then the potential of this body will become zero. Of this side, potential will become zero. So to make potential zero, this whole charge will flow to the earth. When this whole charge flows to the earth, then you can say that potential on the surface is zero. So earthing means a process of sharing charge. When you earthed a body, then its potential becomes zero. Charge may or may not be zero. If this charge is not attracted by any other body, then it will become zero. Otherwise, it will not. Clear with?
Sir, so like, how does this prevent from like this is acts as a safety measure for the electrical appliances?
This is
It was like written in NCRT.
that earthing is a different issue. What we do is when we earth an electrical appliance, we give a path for the current to flow to the earth. Some extra current that generated in the appliance that flows to the earth. So there is a separate wire which is somehow connected to the earth. Through that wire, current flows to the earth. That's earthing for an electrical appliance.
Okay, sir.
Okay. So we have two balls carrying equal charges suspended from a common point by a string of equal length. The length of the string on both the sides is L. The equilibrium separation between them is R. Now the strings are rigidly clamped at half the height. The equilibrium separation with the balls will now become. See, earlier the separation is R. I was asking what will be the separation if you reduce the height to y by 2. The length of the string will remain same. So in these type of question, these are again based on Coulomb's law. So this is charge Q. So what are the forces that are acting over the charge Q, Vishma? Vishma, how many forces are acting over this charge Q?
Weight mg.
Good. Weight mg. Then
Tension.
tension. Very good. Then charge and charge will repel each other Due to repulsion, an electric force will act on the body, right? And let's say this angle is some theta. So we did this in the last class also, this type of question in the last class also. So what we can do is we can just resolve this thing. If this is theta, then this is theta. This will be t cos theta. And this will be t sine theta. T sine theta will balance this Fe. So you can write that T sine theta is equal to the electric force. T cos theta will balance mg. So you can write that T cos theta will be equal to mg. They get cancelled out. T and T will get cancelled out. You will get tan theta is equal to electric force divided by mg. This is tan. Next, what we can do is we can just substitute the values of electric force and mg. See, what is electric force? The separation is R. So electric force is K. It's Q square divided by R square into mg. That's my first equation. This is for this system. Here also, it's reducing the distance, but the equilibrium thing is same. So this is some theta. Let's say this separation is some x. So the same thing. So if you repeat these calculations here also, the same thing. You get t, you resolve this t. For this system also, you can write that tan theta is the same thing. It's kq square. Instead of r, we'll be using x. Earlier, the separation between the charges was r, but now the separation between the charges is x. So kq square, x square, mg. That's second equation. Is it clear how I get this equation for the second system? Noha, Miraj?
Yes, sir.
Now we can
Yes, sir. Clear.
So if I equate 1 and 2, then I get kq square by r square mg is equal to its kq square by x square. Sorry. If y is changing, then this theta will also change. Yes, theta will also change. If this separation is changing, then theta will also change. This is tan theta 1, which is kq square by r square mg. This is tan theta 2, which is kq square x square. Next, what we can do is we can just put the values of tan theta. So how much is tan theta? Tan theta is perpendicular upon base. So here this tan theta is perpendicular. This whole distance is r. Saifullah, how much is this distance? This much.
R by 2.
R by 2.
R by 2. So you can say that tan theta is r by 2 divided by y. So this is perpendicular and this is base y, which is equal to kq square by r square by m. Let's call this as equation number 1. Similarly, in this case, what will be the tan theta if this whole distance is x? Then how much will be this? Miraj, how much will be this distance?
Sir, R by 2.
X by 2. You can say that tan theta is x by 2 by y by 2 will be kq square over x square mg. So this will get cancelled out. You will get x by y is kq square by x square. What is the unknown here, Noah? Which quantity is unknown that we are supposed to calculate? Which one is the unknown quantity that we need to calculate? Arpit, which is the unknown quantity that we need to calculate? Just read the question now. Which one is the unknown here? Saifullah?
X.
X is the unknown. Now we need to calculate X. So what we can do is we can just divide 1 into. So when we divide 1 into 2, we get R by 2i divided by X by Y is KQ square by R square mg divided by its KQ square by X square mg. So this mg will cancel this mg, KQ square will cancel this KQ square, Y will cancel this Y. You are left with R by 2x is X square by R square. So when you cross multiply them, you will get R cube is equal to X cube. So you get X is, it's R by 2. Take cube roots on both the sides. So R by 2 to the power 1. R by 2 to the power 1. A is the correct option. Note it down. Yes, is it clear? Written, can I scroll it further? Arpit, Miraj, written.
Yes, sir.
After this, the next topic is, I mean, we are not doing this question. So there are few topics in chapter number 1 and chapter number 2, which are not given in NCERT, but they are important for your entrances if you are interested in entrances. So those topics start from electric field and potential. Electric field and potential. Okay, do you remember the systems for which we have calculated electric field and potential? Okay, let's recall some system. We calculated field and potential for a point charge. We did field and potential of a point charge. What was the expression for potential due to a point charge and field due to a point charge? Ishma, what was the expression of field due to a point charge? Ishma, expression of field due to a point charge. Anshika, expression of electric field due to a point charge.
Sir, 1/4 epsilon naught and capital Q and small q by r square.
R square, KQ by R square. And what was potential due to a point charge, Noah? If you have a point charge, then what is the expression of potential due to that point charge?
So KQ by R.
KQ by R. We did point charge. After point charge, we did one more system, and that was electric dipole. For dipole, we did both field and potential, so I will not repeat dipole. After dipole, the next system is ring. This ring is not a part of CBSE syllabus, but you will get questions on ring. So the expression of field due to a ring is, let's say you have a ring. This ring is charged. This ring has some charge Q. The radius of the ring is capital R. At a separation x from the center of the ring, let's say this is point A. You're supposed to calculate field over this point. So field over this point A is KQX over 4 pi epsilon naught R square plus X square to the power 3 by 2. This is the expression of field on the axis of the ring. So if you have a ring, then on the axis, this is the field, KQX by R square plus X square to the power 3 by 2. And what is X? X is the separation of the point from the center of the ring. Now, if I say calculate, this is on the axis. If I calculate, if I want to calculate field at the center. Yes, Ishma. What you will do if you want to calculate field at the center of the ring, exactly at the center. What will be the value of X, Ishma, if you want to calculate field at the center? Noah, value of X if you want to calculate field at the center.
Sir, X will be equal to R.
Raj, what will be the value of X you want to calculate field at the center? Raj. Cephalo,
Can you repeat what you said?
How much? What is value of X at center? Miraj.
Sir, can you repeat, sir, what you said, sir?
I said for calculating field at the center, this center of the ring, what is the value of X? Cephalo, how much will be X if I want to calculate this field at the center?
KQ by R square.
What will the value of X I'm asking? If I take this point A to the center of the ring, then how much will be X?
Equals to A.
Not A. See, this X is the separation of the point from the center of the ring. If I'm saying that this point is going to the center, yes, it will be 0. Nah? If I put 0 here, what will be the value of field, Ishma? Ishma, if I put X equal to 0 here, then how much will be the field? Ishma, you're not in class.
Yes, sir, it will be 0.
It will be 0, right? So there's one more question from the field of the ring. He will ask you to calculate point at which field is maximum. He'll ask you to calculate the point at which electric field is maximum. So the field is maximum if dE over dx is equal to 0. This is how we calculate the point at which something is maximum. When you do this, I'm not repeating the entire derivation. You will get that your x will comes out to be plus minus r by root 2. Which means if you move at a distance r by root 2 from the center, then the field is maximum to the right. And the minus of r by root 2 means if you move to the left at a distance r by root 2 from the center, then also field is maximum. So this is the point at which field is maximum. Okay, if I calculate at infinity, Arpit, what will be the value of field if I calculate at infinity? At infinity, if x goes to infinity, then how much would be this E, Arpit? Anshika, what will be the value of E if I take point x to infinity? General question from all. If I take this x to the infinity, then what will the value of field? See, infinity.
0.
0, yes, good. Infinity means a point at which the electrical influence of a charge does not exist. So if electrical influence of charge does not exist at infinity, that means at infinity the field will be 0. This is field. At infinity it will be 0. So that was about ring. Next, he can ask you to plot electric field versus position graph. See, at origin, field is 0. This is x equal to plus r by 2. At plus r by 2, field is maximum. At x equal to minus r by 2, at minus r by 2, field is maximum. So the graph is 0, then it will be maximum at r by root 2. Then this is infinity. At infinity again, your field will reduce. Similarly here, this is maximum at r by root 2, then it will reduce to 0. This is E versus R. Now, instead of field, he can also ask you to calculate potential for a ring. For a ring, the expression of potential is easy. Potential is kq by its r square plus x square to the power 3 by 2. Not 3 by 2, sorry. 1 by 2. This is the expression of potential on the axis. This is on the axis. So if I asked you to calculate potential at the center, then what will you do? So to calculate potential at the center, what will be the value of x? What will the value of x if you want to calculate potential at the center?
So 0.
0. So if I put x equal to 0 here, then your V will comes out to be kq by r. Miraj, this will be the minimum value or the maximum value of the potential? This kq by r, Miraj.
It will be the minimum.
The maximum value potential. Sorry?
The minimum value.
Minimum value. Okay, Arpit, this is the expression of potential, kq by r square plus x square. I'm just asking if I put x equal to 0, then this is the minimum or the maximum one? Arpit. Noah, this will be the minimum or the maximum value? See, how this could be the minimum. See, here denominator is r square plus x square. Here you are decreasing the denominator. Earlier it was r plus x, now it's just r. So if you decrease the denominator, then what will happen with the entire fraction? Saifullah, if I decrease the denominator, then what will happen with the entire fraction?
It will increase, sir.
It will increase. Nah. This is the maximum at the center. Now, if I ask you to plot V versus R graph, see, at x equal to 0, your potential is maximum. At x tends to plus infinity, it's 0. At x tends to minus infinity, it's 0. It's 0, it's maximum, then it becomes. That's potential versus position graph. And this was field versus position. So we have few more systems for which we need field and potential both, which were not included in NCERT. But see, the weightage of those portions which are not in NCERT is less in exams like JEE and MEB. So JEE means that this is just first attempt is almost over of the JEE means. If you look at the paper, then you will realize, okay, this is based on NCERT. I'm not saying it's exactly the questions of NCERT that are repeating, but it's based on NCERT. Those topics which are in NCERT are usually asked. So these are a few topics which were not in NCERT. Just note it down. Then we'll start with the current also. So this is how we'll be doing revision for JEE and NEET. By the time I finish current electricity, we finish the revision of chapter 1 and chapter 2. Then we'll start the revision of current and we'll be doing magnetics in the next one. Even if your target is not JEE or NEET exam, but still these classes will help you in basic numerical solving. Just tell me once you have written, I'll be starting currently.
So done.
Got it? Okay, so let's stop here and we'll continue with current electricity. Written, everyone? Udeep, Noah?
Yes, sir.
1 minute, sir.
सर इसका एक बार ऊपर कर देना थोड़ा पिछला वाला भी। सर ग्राफ सर वो पिछला वाला ग्राफ। डन सर।
Okay, the next is current electricity. So in the last class we did drift velocity. What was drift velocity? The velocity with which electrons drift towards the positive end of the conductor. What is relaxation time mean? We have discussed relaxation time also. What is relaxation time?
सर वो जब इलेक्ट्रॉन्स और आयंस के बीच में कोलिजन होती है तो फिर
Average time between two successive collision between electrons and ions is relaxation. See, relaxation time basically shows the effect of temperature on resistance. Temperature depends on, resistance depends upon temperature. So the dependency of resistance on temperature comes from the relaxation time. That will be discussed in the next topic. But this is the expression of drift velocity, E tau by m. After this drift velocity, the next is a relation between current and drift velocity. Relation between current and drift velocity. See how to relate current and drift velocity. Let's consider a conductor. This is a conductor. The area of cross section of the conductor is A. The length of the complete conductor is L. What is the volume of the conductor, Arpit? How much is the volume of this conductor? Arpit,
Yes, sir.
what is the volume if area of cross section is A and length is L? What is the volume of conductor? Anshika, what's the volume if area of cross section and length are given?
Pi r square.
It's A into L, na? Volume is area of cross section multiplied by length. That's volume. Area of cross section of the conductor multiplied by length of the conductor. That's the volume of conductor. So this A is area of cross section. L is the length of conductor. Then you have small n. Small n means number of electrons per unit volume. The number of electrons passing through the unit volume of this conductor is small. I need total number of electrons, that's capital N. Capital N are total number of electrons. Apit, can you calculate capital N in terms of A, L, and small n? Yashika, can you convert capital N in terms of small n, A, and L? Good. See, the total number of electrons can be written as number of electrons per unit volume multiplied by the volume of conductor. So capital N is number of electron per unit volume is small n. The volume of conductor is L. That's the total number of electrons. See, how we calculate total number of electrons? Number of electrons in unit volume multiplied by total volume of the conductor. That's total number of electrons. Now, let's say in some time t, some charge delta Q pass through the conductor. Or I can say in time delta T, delta Q charge, or you can say n electrons pass through the conductor. Pass through the conductor. Now, can you calculate delta Q now? Your n electrons are passing in time t. How much is charge, Hishma? In time delta t, capital N number of electrons are passing through the conductor. How much is charge, Hishma? Current charge, yes. Jasola, how much would be the charge that's flowing through the conductor in time t? See, can I write this as delta Q is number of electrons multiplied by charge on each electron? That's delta Q. No? The total number of electrons are in. How much is charge on one electron, Arpit? How much is the charge on one electron, Arpit? Anshika, how much is the charge on one single electron?
So 1.6 into 10 raised to power negative
Minus
90.
90. You can call it as E. Arpit, are you in class here? So this could be written as NaL multiplied by E. This is the charge. So we know that charge passing through the conductor in time delta T is delta Q, which is NaLe. I need current through the conductor. I need current through conductor in time delta T. So the current through the conductor in time delta T is its charge divided by time. So how much is charge? Charge is NaLe divided by that. This is equation. What is L by T? L is length divided by time. What is distance by time? Anshika?
Speed.
Speed. So we call this as drift velocity. This is the drift velocity. Velocity with which electrons move in a conductor. This is equation number 4. Arpit, just switch on your video. Huh? Switch on your video. I started the focus mode so no one else can see you.
Okay, sir.
मुझे शक है कि तुम ना इधर उधर फिर रहे हो. Switch on your video. So Na L by delta T is Vd multiplied by E. So you can write this as it's NeA Vd. So this is the expression of current. Current flowing through a conductor is NeA Vd. N is number of electrons per unit volume. E is the electronic charge. A is area of cross section, and Vd is the drift velocity. Is it clear?
Yes, sir.
Arpit, what is this? You are using some screensaver or something. No, that's fine. So this is current, which is NeA Vd. Yeah? So that's the relation between current and drift velocity. Current is directly proportional to drift velocity. If you increase drift velocity, then current will increase. And this is what I will do with anyone who is not responding in class. If you don't respond, I'll ask you to open your video. Okay, slow it down. Tell me if you have doubt in any step. Bhishma, Saifullah, Noha, Yashika, any doubt?
No, sir.
No,
No, sir.
No, sir.
Tell me once you have
Can you
written. I will scroll it. Arpit, written?
Yes, sir. So can you scroll?
Yes. Written, everyone? Anshika, Noha, Saifullah.
Yes, sir.
After this, The next is, after this relation between current and drift velocity, the next topic is Ohm's law. See, numericals on this topic will come once we have finished all definitions. Ohm's law. So Ohm's law says if a constant current can say that if temperature and other physical conditions are constant, then, which means if you take a conductor and you don't vary its temperature, the temperature is constant, and other physical conditions like area of cross section, length, pressure, not changing anything, then potential difference across the ends of the conductor, is directly proportional to the current flowing through. Or you can say that V will be directly proportional to Y. When you remove this proportionality sign, we use a constant which is R. This R is known as resistance. So this is Ohm's law, that potential difference is directly proportional to current. So if I plot I versus or V versus I graph, then that graph will be a straight line. This is Ohm's law. Ohm's law means V versus I graph is a straight line. Straight. Now we can divide this conductors into, on the basis of Ohm's law, we can divide material into two broad categories. You have one type of material which does not follow Ohm's law. Then you have another type of material which can follow Ohm's law. So we have two types of materials. Types of material on basis of Ohm's law. So on the basis of Ohm's law, we can divide materials into two categories. One is ohmic, another is non-ohmic. So ohmic are basically those materials which follow Ohm's law. Ohmic are those materials which follow Ohm's law. What will be the shape of graph if they follow Ohm's law?
Straight line.
Straight line. If they follow Ohm's law, then V versus I graph will be straight line. V versus I graph is a straight line. So for ohmic material, V versus I graph is not a curve, that's a straight line. So this is V and this is I, then your graph will be a straight line. The examples of ohmic materials are conductors. All conductors are ohmic. You can take carbon resistors. Carbon resistors are ohmic. That means V versus I graph is a straight line. For non-ohmic, these are those materials which don't follow Ohm's law. They don't follow Ohm's law. V versus I graph is not a straight line. Will be a curve, it will not be a straight line. So it will not be a straight line. That means you have following variations, like this can go this way, this can go in this way. So V versus I graph will not be a straight line. These type of materials are known as non-ohmic. In your syllabus, the examples of non-ohmic materials are like semiconductor device, like diode, LED, light emitting diode, LED bulb that you use is an example of non-ohmic material. If you take an LED and you plot V versus I graph, then that graph will not be a straight line. Then that graph will be a curve. Then you have transistors in your syllabus. Transistors that we use in microphones. In microphones, we use transistors. So these are some materials which are not ohmic. They don't follow Ohm's law. V versus I graph will not be a straight line. So that is about Ohm's law. Just note it down. Then we will do what is resistance and what's the cause of resistance. Is it clear, everyone? Doubts,
Yes,
discussions?
sir.
Ishma, Noha, Munir?
Sir,
Yes.
sir, does it depend upon area of cross section?
No. It's independent. Area of cross section should not change. See, all physical conditions should remain constant. If you change the area of cross section, then your voltage can change, then your current can change. So we keep all physical conditions constant. We just vary voltage and we vary current.
Okay, sir.
Okay, Alia. आप बहुत बाहर जाने लगे ना?
So can you scroll?
Yes. Written, Arpit?
Yes. Sir,
Yes.
sir, all insulators are non-ohmic, right?
No. Insulators may be ohmic or not. That depends upon the material. Usually the semiconductor materials are normal. Insulators have high resistance, but they follow Ohm's law.
Okay, sir.
Any doubt, Alia? MEB?
No, sir.
Sir, what are carbon resistors?
What are
Carbon resistors.
resistors? Like when we the resistors that we use in circuit are usually made of carbon. Have you seen कभी देखा है मोबाइल फोन चार्जर तोड़ा है कभी? मोबाइल फोन चार्जर तोड़ना उसमें ना तुम्हें cylindrical से colored कुछ चीजें दिखेंगी. They are basically carbon resistors. So the resistors that we use in circuit are usually made of carbon. We call them as carbon resistors. If you look at any circuit, now you will find some cylindrical, colored cylindrical circuit elements.
Yes,
Those
sir.
cylindrical circuit elements are the resistors, carbon. Written, everyone? Ishma,
Sir, wait a second.
Yes, sir.
Stefula, written?
Yes, sir.
Okay. So after these ohmic and non-ohmic, the next is resistance. See, what do you mean by resistance? Resistance means obstruction offered by conductor in the flow of current. The obstruction that a conductor offers in the flow of current is resistance. This is obstruction offered by conductor in flow of current. So the obstruction that a conductor offers in the flow of current is known as resistance. So not just conductor, by any material, by material in the flow of current is resistance. See, what is the cause of resistance? The cause of resistance is collision of electron and ions. When the current flows through a conductor, then electrons continuously collide with the ions. That collision of electrons and ions is responsible for resistance. Remember the cause of due to that collision, we were having a term like relaxation time. That collision of electrons and ions is the reason behind resistance. Collision of electrons and ions is responsible for resistance. The cause of resistance is the collision between electrons and ions. This collision between electrons and ions is the cause of resistance. Or we calculate resistance. Resistance is simply the ratio of voltage and current, V by I. It's a scalar quantity. SI unit is ohm. If you want, you can calculate resistance in microscopic form. Microscopic form means the expression of resistance in terms of mass of electron, in terms of relaxation time, in terms of length of conductor. That is the microscopic form. So although it's a very straightforward derivation, see, we start from this expression, NEAVD. What is the expression of drift velocity, Anshika? Anshika, we derived drift velocity in the last lecture. What is the expression of drift velocity? Yes, it's EE tau divided by M. So you can substitute drift velocity here. So you will get I is, it's NEA, it's EE tau by M. Next, you can write this as, this is NE square E tau by AM. Now what you can do is, you can write your electric field as the ratio of voltage and current. This is what we did in chapter number 2, that electric field is gradient of potential. So this is voltage. Voltage can also be written as potential difference, and this is the length of current. So if I do this substitution here, then I will get I as, it's NE square tau A by M into V by L. Instead of E, I wrote V by L. So you can write this as, it's V by I is
It's ml by a n e squared tau. And this V by I can always be written as R. So that's resistance ml by a n squared. So this is the resistance offered by a material in the flow of current. That's ml by a n squared. So resistance depends upon, see here, m is electronic mass, mass of electron. L is length, A is area, N is number density of electrons. N is number density. What was number density, Anshika? Anshika, you're not responding. Noha, what is number density?
So number of electrons per unit volume.
Good. Number density means number of electrons per unit. Number of electrons per unit. Tau is relaxation time. So that is the expression of resistance. AML by ANE squared tau. This is the expression of resistance in microscope. So this expression shows that resistance depends on first one. Resistance depends upon mass. So mass does not change, so no need to write mass. It depends upon length. Resistance is inversely proportional to area of cross section. It depends upon N. N means nature of material. It's inversely proportional to N. N depends on nature of material. Different type of materials have different number density. Like if you compare copper and iron, the number density of copper is more than that of iron. That's why the resistance of copper is less than that of iron. It depends upon the relaxation time here. From relaxation time comes the dependency of temperature. Relaxation time depends upon temperature. So resistance depends upon four characteristics, depends upon length, it depends upon area, it depends upon nature of material, and it depends upon the temperature also. After resistance, we can define one more term, which is resistivity, but first write resistance, then we'll do resistivity. Doubts? Alia, Ishma, Yashika?
No, sir. No, sir.
Slow it down.
Sir,
Mhm.
so can you explain the second point?
Which line?
Sir, collision of electrons.
See, when a current flows through a conductor, what happens? Electrons move. During movement, electrons collide with the ions. And during that collision, the motion of the electrons gets obstructed. And what is resistance? It's nothing but the obstruction offered by the material in the flow of current, right? So when the electrons are moving, they collide with the ions. So what is the obstruction? That obstruction is that due to that collision only.
Yes, sir.
So that collision is responsible for resistance.
Got it.
If you don't have collision, you will not have it. Any other doubt?
Sir, please go.
So the first part is majorly in a theoretical. This 33% of current electricity, that's theoretical. You can do some numericals only after finishing all definitions. We have four more topics left. Then we can start.
Yes, noted. Jasola, Need, Noah.
Yes, sir.
So
Yes, sir.
next is resistivity. Listen. On what factors resistance depends, Ishma? Ishma.
In
So
Yeah.
length
On what
will-
factors resistance depends?
length,
Hmm.
nature of the material,
Hmm.
temperature,
Okay. And area of cross section, right? So it depends upon geometry also. What are the two terms that are included in geometry out of these four? Ishma. Out of these four, which are the two terms which depends upon the geometry?
length and
Length and
area.
area. So resistance also depends upon length and area of cross section. When we define resistivity, we are basically trying to define a term which does not depend upon length and area of cross section. So when we define resistivity, we are trying to define a term which is independent of length and area of cross section. That's resistivity. Resistivity is independent of length and area of cross section. So how we define resistivity? We say that length is directly proportional to length. Resistance is directly proportional to length. Resistance is inversely proportional to area of cross section. When you remove the sign of proportionality, you use a constant rho, so that R is rho L by A. So that is resistance, R is rho. And this rho is known as resistivity. So from here, if you want, you can write your rho as just cross multiply them. So it will be RA divided by L. That's your resistivity. Resistance into area of cross section divided by length. That's resistivity. You can do one more thing. You can use this expression of resistance. See, R is ml by A square tau. If I use it here, R is ml by A n E square tau into A by L. Now see, this A will cancel A, L will cancel L. Your rho will comes out to be M by N E square tau. So see, resistivity does not depend upon length and area of cross section. It also represents the obstruction offered by material in the flow of current. But the thing is, this is independent of length, it's independent of area of cross section. That's resistivity. SI unit is ohm meter. From this expression, if you want to write the definition that's usually given in book, you can say if your A is 1 meter square, if your length is 1 meter, then you can write that rho is equal to R. So you can say resistivity is the resistance of a conductor having unit length and unit area of cross section. So you can say that resistivity is resistance of conductor having unit length and unit area of cross section. So resistivity is the resistance of a conductor whose length is unity, its length is 1 meter, and area of cross section is also unity, its area of cross section is also 1 meter square. The resistance of that type of conductor is known as resistivity. So resistivity depends upon temperature and nature of material. It's absolutely independent of length and area of cross section. It depends only on nature of material, and temperature. It's independent of area of cross section. It's independent of area of.
So that's resistivity. So these are two important relations for resistivity. One is this, R is rho L by A. Another is this, rho, which is N by A. So
Can you speak?
yes. Okay, after resistivity, the next definition is conductance. The next is conductance. See, what is conductance? Conductance is inverse of resistance. Inverse of resistance is known as conductance. The formula for conductance is conductance G is 1 by R. Its SI unit is ohm inverse. This is also known as MHO. That's conductance. After conductance, we have another quantity which is known as conductivity. Conductivity is simply the yes.
What is MHO?
Sorry,
What is MHO, sir?
that's the name of the unit. Ohm. Either you write ohm or you can write MHO. Basically, what people do is they just reverse. Ohm is OHM. Inverse of ohm is MHO. Okay, so
Okay.
this is how they write this. Conductivity is simply the inverse of resistivity. The inverse of resistivity is known as conductivity. We represent it by sigma, and sigma is just 1 by. SI unit is ohm inverse meter. See, you can write one more expression for conductance. See, resistance was ml by AD square tau. So the inverse ANE square tau divided by ml can also be written as a formula for conductance. Similarly, for conductivity, you can write this as NE square tau by N. We wrote rho in the last, like rho was mne squared by tau by N. So we write from there, we write sigma as NE square tau by N. There is another one more quantity which is known as mobility. Mobility is just the ratio of drift velocity and electric field. So the ratio of drift velocity and electric field is known as mobility. We can write mobility as drift velocity divided by E naught. That's mobility. VD by E. SI unit of mobility is its drift velocity, which is meter per second, by electric field, which is Newton per Coulomb. So it's Newton inverse meter Coulomb second. After mobility, last term is current density. Then we will do numerical. After this current density, we can solve it. So what is current density? Current density is current per unit area. Current per unit area. So this is a conductor. The area of cross section of the conductor is A. Some current I is passing through this area, and this current is perpendicular. So you can say that current density J is its I by A. Or you can say that this I is J multiplied by A. So that is current density, current per unit area. If current density is not uniform, let's say if J is variable, if J is non-uniform, then instead of multiplication, you will simply integrate it, it's J dot dA from some initial to final limit. That will be your current. One more thing, current density is a vector. Direction is same as that of electric field. Direction is same as that of electric field, which is same as that of current. Its SI unit is ampere per meter square. So usually in NCRT, in all questions, J is uniform. But if you have a non-uniform J, then to calculate current, you will simply integrate J dot. And there is one more relation which is known as microscopic form of Ohm's law. Microscopic form of Ohm's law. And that microscopic form says J is equal to sigma E. J is sigma, which is current density, that resistivity, and then E, electric field. E is electric. And the sigma is yours conductivity. See, the next thing is why we call this as Ohm's law. See, we write Ohm's law as V equal to IR. Ohm's law is the relation between voltage, current, and resistance. So when we write this expression, instead of voltage, we are using electric field. Instead of current, we are using current density. Instead of resistance, we are using current. So this J is equal to sigma E is again sort of Ohm's law, which we call microscopic form of Ohm's law. Note it down, then we'll start numerical. Numerical will include all these topics, right? Starting from drift velocity to this. Any doubt in it? Unib, Yashika, Saifullah, Hishma?
No, sir. Sir, please go.
Sir,
Yes.
sir, J is current density.
J,
J. So what is J?
current density.
Okay, sir.
Written, everyone? Alia, Saifullah, Udeep, Noah, noted?
Yes,
Yes,
sir.
sir.
So let's start the query. So the first type of questions that we will do will be based on this relation R is rho L by A. That resistance is resistivity into length divided by area of cross section. So the question says length of a conductor increase by 2%. Calculate percentage change in resistance and resistivity. So will there be any change in resistivity if I am changing the length of the conductor? Yes or no?
No, sir.
Why not?
Because it does not depend.
It's independent of length and area of cross section. So no change in resistivity. So when we change area of cross section or length, then there's no change in resistivity. Resistivity will not change. To calculate change in resistance, what we can do is let's consider this conductor. The area of the cross section of conductor is A, the length of the conductor is L, So the resistance of the conductor is rho L by A. That's my first equation. Next, what we can do is, if we increase its length, let's say the length becomes L prime, area of cross section becomes A prime, then its resistance will become its rho L prime divided by A prime basically. So the next task is to somehow convert L prime in terms of L and A prime in terms of A. So your L prime is, it's L plus 2% increment. So it's 2% of L. So we have L plus 2 by 100. So we have 100 into L by 100. So your L prime is 1.02 L. So to relate old area A and the new area A prime, we have to relate A and A prime. To relate this, we can use that volume will remain constant. Volume will not change. So earlier, the volume is A into L. Now the volume is A prime into L prime. So you can write that A prime is AL divided by L prime. And how much is L prime? It's 1.02 L. So you can write this as, this is AL divided by 1.02 L, gets cancelled out. So your area is, it's A by 1.02. And this is something which is very quite straightforward. If you increase length, if you stretch a conductor, its volume is not changing. It's very obvious that its area of cross section will decrease. When you stretch a conductor, its length increases, area of cross section decreases by the same factor, so that volume remains constant. So in this particular expression here, I can use the value of L prime and L prime. So L prime is 1.02 L and A prime is A by 1.02. So this is 1.02 square into L by 1.02 square into L.
Excuse me, sir.
Into L. Yes, sir.
Sir, if we like stretch something, so will it not, like volume will not change now?
Yeah, volume will not change. You're not adding or subtracting the material. If you take some clay, the volume will remain constant. You can stretch it or you can compress it. The length and area can change, shape can change, but not the volume.
Okay, sir.
So what we can do is here, see, from this is equation number 3. Let's substitute 1 in 3. When we substitute 1 in 3, we get R prime is 1.02 whole square. It's 1.0404. Rho L by A could be written as that. So R prime is 1.0404 into R. Next, you need percentage change. See, percentage change is final resistance minus initial resistance divided by initial resistance multiplied by 100. So it's 1.0404 R minus R by R multiplied by 100. 1.0404 R minus R is 0.0404 R by R multiplied by 100. R is 2 R. So this is 4.04%. If you change length by 2%, then the resistance of the conductor will change by 4.04%. Hold on. Is it clear?
Yes, sir.
Roha? Vishma?
Yes, sir.
Roha? Vishma is not in class, huh?
Yes, I'm there.
Yeah. Great. So I need 4 more lectures to finish this current electricity. So by that time we will be finished. We will finish that revision of first and 2 chapters, giving JE and needed. Yes, written everyone.
Yes, sir.
Okay, so let's stop here. There's few more numericals on this concept. We'll do it in the next class. If you have doubts, that we can discuss. Class is over. If you have doubts, we can discuss.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you.